Welcome to ZoomInData. Hello everyone. Thank you for joining this focused session on state management in durable functions. We will cover how durable functions manages state reliably, the orchestration history table, replay mechanism, entity state persistence, limits, pruning, versioning, migration, cost optimization, and best practices to avoid common pitfalls. If you are preparing for certification, an interview, or building long-running, reliable workflows, this session will give you clear, ready-to-use knowledge. If you find it helpful, please like, share, and subscribe to ZoomInData for more Azure deep dives. Let us begin. How does state management work in durable functions? Durable functions automatically manages state for orchestrations and entities behind the scenes. State is stored durably in Azure storage, blobs, tables, queues. This makes workflows resilient to failures and restarts. The runtime saves every step of the orchestration history so it can replay and resume exactly where it left off. For entities, state is persisted per entity ID and updated transactionally. Explain orchestration history table. The orchestration history table is an Azure table storage table that records every event in an orchestration's lifecycle. Each row represents an event: orchestrator started, activity scheduled, activity completed, timer created, event raised, etc. The history is appended only. It grows with every action or wait. The runtime uses this history to replay the orchestration during recovery or resumption. What is replay in state management? Replay is the process where the durable function's runtime re-executes the orchestrator code using the saved history. During replay, the runtime reads the history table and fast-forwards to the current point without rerunning completed activities. This ensures deterministic behavior. The same decisions are made even after failure or restart. Replay is completely transparent to the developer. How do you avoid non-deterministic code? Never use random numbers, datetime, now, GUID, new GUID, or thread. Sleep in orchestrator code. Use durable timers, context, current huge datetime, create timer, instead of system time. Avoid side effects like console output or external calls in orchestrator functions. Keep orchestrator code pure. All side effects must go in activity or entity functions. Explain entity state persistence. Entity functions persist state per unique entity ID in Azure table storage. State is updated transactionally. Each operation locks the entity briefly. The runtime saves the current state and event history for replay if needed. State is queried or updated using entity ID and operation name. What is the role of durable storage? Durable storage, Azure Storage, is the backbone of state management in durable functions. It stores orchestration history, entity state, timers, and messages. It provides durability. State survives restarts, failures, and scaling events. It enables replay, resumption, and reliable execution without data loss. How do you handle large orchestration state? Keep orchestration history small. Avoid large loops or long-running orchestrations. Use continue as new to reset history periodically for eternal or long-running flows. Offload large data to external storage, blob, Cosmos DB, and parse references. Use sub-orchestrations to break complex workflows into smaller units. Explain state size limits. Orchestration history size limit is 1 megabyte per instance by default, configurable up to 4 megabytes. Exceeding the limit causes out-of-memory exceptions during replay. Entity state has no hard limit, but large entities slow performance. Monitor history size with application insights or custom metrics. What is the history pruning feature? History pruning automatically deletes old history entries after a configurable retention period. It reduces storage costs and improves replay performance for long-running orchestrations. Configure in host. JSON. Extensions. Durable task. History retention in days, 30. Pruned history is still recoverable from checkpoints if needed. How do you query orchestration state? Use the Durable Functions Management API or SDK to query status. Example: await client. Get status async. Instance id. Returns runtime status. Input, output, history size. Query history table directly in Storage Explorer or Log Analytics. Use custom events for business-level state tracking. Explain entity function signals and calls. Signals are one-way messages sent to an entity to update its state, fire and forget. Calls are two-way operations. Entity returns a response to the caller. Use signals for updates, increment counter, and calls for queries, get current value. Both are asynchronous and safe for concurrent access. How do you back up entity state? Entity state is stored in Azure Table Storage. Back up the storage account. Use Azure Storage Geo-Redundant Replication for automatic backup. Export entity data periodically using Azure Data Factory or custom scripts. Restore by re-importing table data and replaying events if needed. What is the difference between orchestration and entity state? Orchestration state is the history of events, replayable and linear. Entity state is the current value of a persistent object, updated transactionally. Orchestrations are temporary. Entities are long-lived and addressable by id. Orchestrations manage process flow. Entities manage state like counters or carts. How do you handle state in fan-out scenarios? Fan-out creates parallel activities. State is managed by the orchestrator. Use task. When alter wait for all tasks and aggregate state. Persist partial results in external storage if orchestration history grows too large. Ensure activities are idempotent to handle replay safely. Explain state dehydration, rehydration. Dehydration is when the runtime saves orchestration state and unloads it from memory. Rehydration is when the runtime reloads the state from history and resumes execution. This happens automatically during idle periods or scaling events. It enables high scale and resilience without constant memory usage. How do you debug state issues? Use application insights to trace orchestrator and activity calls. Query history table in Storage Explorer to see event sequence. Use Durable Functions Inspector tool or custom dashboard. Add custom logging with correlation IDs to track state changes. What is the impact of state on performance? Large orchestration history slows replay, increases latency on resumption. Frequent state updates in entities can cause contention. High state size increases storage costs and memory pressure. Use history pruning, continue as new, and external storage to optimize. Explain versioning state schemas. State schema changes require versioning to avoid breaking existing instances. Use orchestrator version parameter and conditional logic for old versus new state. For entities, store version number in state and handle upgrades. Test migrations with parallel old and new orchestrators. How do you migrate state between versions? Use continue as new with version parameter to start new instance with old state. Map old state to new schema in orchestrator code. Run old and new versions side by side during transition. Use external storage for state migration if history is too large. What is the role of Task Hub? Task Hub is the logical grouping of orchestration and entity state in Azure Storage. It consists of queues, tables, and blobs for history, timers, and messages. Multiple task hubs can exist in one storage account for isolation. Configure Task Hub name in host. JSON. What is the role of Task Hub? Task Hub is the logical grouping of orchestration and entity state in Azure Storage. It consists of queues, tables, and blobs for history, timers, and messages. Multiple task hubs can exist in one storage account for isolation. Configure Task Hub name in host. JSON. Explain state in critical sections. Critical sections lock the entity during operation to ensure atomic updates. State changes are safe from concurrent modifications. Use for counters, balances, or flags where race conditions are critical. Runtime handles locking. No extra code needed. How do you monitor state growth? Query history table size in Azure Storage Explorer or Log Analytics. Use Application Insights custom metrics for orchestration count and history size. Set alerts on storage growth or history size exceeding thresholds. Review weekly to catch runaway orchestrations early. How do you optimize state storage costs? Enable history pruning to delete old entries automatically. Use continue as new to reset history in long-running flows. Offload large data to Blob or Cosmos DB. Store references only. Choose geo-redundant storage only for critical workloads. Use locally redundant for others. Best practices for state management. Keep orchestrator code deterministic. Avoid random numbers, current time, or side effects. Use continue as new for long-running or eternal orchestrations. Make activities idempotent to handle replay safely. Offload large payloads to external storage. Pass references only. Enable history pruning and monitor state size regularly. Use entities for persistent state instead of orchestration history when possible. Test replay and failure scenarios thoroughly. Thank you for watching this complete guide to state management in durable functions, from orchestration history to entity persistence, versioning, and best practices. If this session helped you with certifications, interviews, or building reliable workflows, please like, share, and subscribe to ZoomInData. More Azure deep dives are coming soon. Stay connected and keep learning. Thank you. See you in the next video.